6.7, percentile sampling, and again, reviewing or finding z-scores. Actually, no, we're going to use the opposite. Instead of using z-scores to find probability, we're going to work backwards. We're going to use the probability, look the information up backwards, and find the z-scores. So we're doing a reverse of what we were doing last lesson for the z-scores part. Before we do that, let's just do some warm-ups to make sure we are on the right track. Don't forget our special notation that we have for normal distribution. So according to this, ladies and gentlemen, hopefully you remember that the mu equals 10. Standard deviation is the square root of the second number, so that equals 2, because the square root of 4 is 2. And I didn't mean to write over the question. All right, so use z-scores to find when x is less than 9. When x is greater than a 13, and when x is between 7 and 11. All right, so the first thing we need to know is that the 10 is in the middle, okay, because that is the mean, right? So we know what we're looking at is 9. Well, if you take a look and take one standard deviation away, it's 8. So 9 occurs in between the two of them, so you can't use your 68, 95, 99.7 rule because it doesn't fall on an even standard deviation. So 9 is our spot where we want, and we want to have less than, so we're looking at all the area. And remember, less than is a good sign. Okay, we can do less than. Greater than, we've got to do the opposite, remember? So it says to use z-scores because we can't use the 66, 95, and 99.7 rule. We've got to use z-scores. So first of all, we do our z formula from last day. So the datum, subtract the mean divided by the standard deviation, which is 2. Okay, so plug that in your calculator and you're going to get negative 0.50. Double check, folks, to make sure your negative is reasonable. For example, if your datum is less than the mean, you know it's going to be negative. If it's greater than the mean, it should be positive. Okay, and you can carry that to another, oh, sorry, we already have 2 decimal places there. Just going to make sure we had 2. All right, so now we know the z-score, so don't forget our proper communications. We're going to say probability of x being less than 9 equals the probability of z being less than negative 0.50. Okay? All right, then you look that up in your charts. I think it's 606 and 607, and you're going to have 0.3085. Plugging that in, so that equals about 31%. All right. Second example, ladies and gentlemen, if we take a look, the mean is in the middle. Then we use our standard deviation, so we got 12, and then we got 14. But this time, folks, it wants greater than. So first of all, 13 is not at a standard deviation, so again, you can't use that rule. And we've got to also be careful because this is a greater than sign. We have to, don't forget to switch and do the opposite. Okay? If you forget about that, remember on page 606 and 607, one of those pages on the top, there's a graph that shows you it has to be a less than sign, okay? So to switch greater than to less than. So we have to do kind of like the opposite. But before we do that, let's find our z-score. So z equals the data point, which is 13, subtract the mean, which is 10, divided by 2. Now, looking at this, our value should be positive because our data point is greater than our mean, and you should get 1.50. Okay. Now, we're going to change our probability from the x to 1 minus, so then we get the less than first. Everybody okay with that? Okay. And then, I apologize, I forgot my equal signs in there. And then we're going to change the x value into the z-score. So instead of x, which I just wrote down, I'm going to change it to a z. So z is less than 1.5. Okay, so it's going to be 1 subtract, look on the positive side for your z-score there. Okay, subtract it from 1, and you get a very small number. Okay, so if we take a look at doing percentages, that's about 6.7%. Okay, and folks, it's a very small area under the graph, so yes, it should be small. Make sure your answers are reasonable. All right, last one. So taking a look here, This one might be a little tricky, okay, but we'll do it together. So we know 10's in the middle. If we subtract, it's 8, 6, add 2, which is 12, and actually that's all we need. So 11 is our top limit, okay, and our lower limit is 7. Both of those are not on equal boundaries, okay, and we got to figure out how we're going to do this. Okay, because using the z-scores is only less than, and it starts right from the very beginning. But there's a calculation we can do here to calculate that. But what we need to do is find, hey, what's the z-score at our lower limit, which is at 7, and what's the z-score at our higher limit, which is 11. And then we're going to work this out. So let's do the 7 first. So 7 subtract 10, it's below, so we should have a negative number. Okay. And then we do the upper limit, which is 11. It's above, so it should be positive. Okay. All right. Now, this is going to be interesting to show this. So we can do this, but I'll show you how this works. So probability where x has to be between 7 and 11 equals, okay, we've got to break that down. How do we get this specific area? Well, if we take the upper limit, which is the probability with x that's less than 11, and we subtract the probability when x is less than 7, hopefully you see that out. So let me see if I can do some colors here. So if I take this whole area and do that, and then I subtract this whole area, then what are you left with? Okay, so you're left with the information inside. And the cool thing about this is that they're both less than. Okay, so now what we need to do is substitute these in for probabilities related to, instead of probabilities with the x variable, we're going to do probabilities with the z-scores. So the upper limit was 0.50, but that's okay, you can just leave the 0 off. And then we are going to subtract the upper limit, so probability where z is less than negative 1.50, right? Okay. And then we look those up in our chart. So you've got 0.6915, subtract 0.0668, subtract them through, and you're going to get 0.6247, which equals 62%. So 62% of the data is in between 7 and 11. Right there. Okay? All right. And that's the way you can use z-scores, folks. You might have to subtract a couple different areas to get the desired area under the curve. All right, one quick little warm-up thing here. Taylor Swift found out that she was in the 97th percentile for her SAT scores. If you're planning to go to the States, you need to do standardized testing, which allows you to have admission. If you're high enough, universities will accept you and colleges will accept you based on your scores. Okay, so what does this mean? So just for now, if she's in the 97th percentile, that means that she beat 97% of the people. Okay? I'm sorry. And I believe it's based on a yearly basis. So she beat 97% of the people who wrote SATs. Okay, and we'll assume it's that year. So what does that look like? That means probability where X is greater than Taylor. Sorry, that Taylor's greater than X, or X was less than Taylor, equals 0.97. So if we take a look, if it's normally distributed, which usually happens for standardized testing, okay, so if she's 97 percentile, she's probably right here, okay, so she beat all these people, okay, so that would be at the 97th percentile, which we don't know based on a z-score yet what that looks like, but she beat 97%. So what you want to remember, guys, is that the percentile is the same as the what? Probability or the area under the curve. All right, awesome. Okay, so let's take a look a bit more at percentiles and working backwards with probabilities. All right, so what we're doing is we're going to make probability statements about normal distributions. Okay, we will learn how to deal with, again, this is continuous data, and we will learn, I believe, next class how to deal with discrete data, because you might be wondering, hey, what the heck's going on with my discrete data? How do I make it work? Okay, so what we're going to take a look at is SAT scores are normally distributed with an average of 500 and a standard deviation of 150. Okay, so Harry Styles got 400. What percentile is this? Okay, well, we don't know right away what percentile this is. Okay, but if we take a look on, if we do a normal distribution curve, hopefully you're getting a little bit better at drawing them. I know it takes a while. I'm not even perfect on it either. Okay, we know at the middle it's 500. Okay, we know standard deviation. We can go below, so we subtract 150, which should be 350. And you could go above, however, that's where our 400 lies. So again, 400 lies in between. So we can't use the 68, 95, 99.7 rule. So what does that mean? We have to equate it to z-scores. Okay, so what we're going to do is find the z-score first. Okay, so z-score equals his mark, subtract the average, divided by the standard deviation. So z-score, in this case, if you do the calculations, is negative 0.67. Okay? All right. So what we want is we want to find out what's the probability that he is less than 400. Okay? All right. Well, we got to translate it to z-score, so that's going to be the probability that z is less than negative 0.67. Okay? And probability, oh, sorry, we already did that. Now we just look on our negative side of our z-score chart. Should get 0.2514. Okay, and folks, I'm not sure if these stats are actual or factual, or if someone just made it up. I borrowed this slide, so and I'm not sure the origin of it. So I wouldn't say that these are mathematically correct statistics. Okay, so I have no idea. All right, so that's about what, 25, around 25%. Okay, so therefore Harry is at the 25th percentile for SATs. Okay? All right. What mark would put Selena Gomez in the 80th percentile? Oh, so here's the thing. We give you the percentile, and we want to find out what mark. So we need to find what x equals. Okay? So in order to do this, this is where we work backwards. Okay? So let's see how smart Selena is. Okay? And again, I'm not sure if this data is statistically accurate or not. Okay? All right, so what we want, in this case, it's going to look a little funny. Probability of x, our random variable, being greater than x, okay, because we've got to find that value, equals 0.800. Because I took 80%, right? 80th percentile, change it from a percent to a decimal, okay? And this is the x that we're trying to find. So we need to solve. All right? Okay. So what we need to do is we need to work backwards. So in the past, we had a z-score, we looked it up, and that was our percentile. So we've got to go backwards. We know to look up the probabilities. So which ones are closest in the chart for this? So here's our plan. We're going to go to the table, and look inside the table. Not on the edges where you had the z-score. We're going to work backwards. So look inside the table. Okay? All right. So let's make a quick little chart. We want to find the highest, the one that's the highest, the one that's closest above and closest below. So probabilities. So look in there, and then we'll find the z-score. So what's the closest one that's lowest to 0.800? Actually, go and take a look, folks, because you need to practice doing this. Pause my video if you need to, and go get it. Okay, so here we go. So the lowest one was 0.7995, and the z-score that corresponded to that, then you look on the outsides of the chart. Okay, now go back to the inside of the table. Which one's the closest one that's just above? 0.8023 should be right beside it. And that z-score should be 0.85. Now, ladies and gentlemen, is there one that's closer to 0.800 than the other? Well, this one is very close because it's less than off. If you're not sure, take 8 and subtract this number, or take this number and subtract 0.8, right? Okay, so we're going to use this one. Because it's closer. Now, folks, one thing I want to mention to you. What if both of these are equal distance apart? Then guess what? I would take the average between the two z-scores. So if they were both the same, then I would have 0.845. Okay? If they're equal distance apart, then average them. Otherwise, take the closest one. Okay, everybody got that? Make sure you remember that. Hint, hint, hint. All right, so now that we've got our appropriate z-score, so we now know z equals 0.84, last thing to do is to plug it in the formula. So now we're going to use z formula, or z-score formula, to find datum, or find x. Okay. So we know z equals x minus mu divided by standard deviation. Okay, so here's where it looks a little different. Z is 0.84, so it goes on the left. Equals x, that's what we're going to end up solving. Okay, we know our mean is 500, and we divide by the standard deviation, which was given as 150. Okay, now we have to rearrange and solve. Okay, first thing we want to do is cross multiply. Okay, so to cross multiply, we're going to end up with 150 times 0.84 equals x minus 500. Okay, multiply this through, so you get 126 equals x minus 500. Move the minus 500 over. Okay, so 126 plus 500 equals x. So you're going to get here that x equals 626. Okay, so what does that mean? For her to have an 80th percentile, she would have had to have a score of 626 on her SATs. So, therefore, Selena needs a score of 626 on her SATs to get the 80th percentile. Okay, great. All right, let's try another one here. Okay. Now, this time we're looking for Z, okay, as it relates to the z-scores. Okay, so this one actually isn't as isn't as difficult as the first one. So what we're going to do is, what do we start with? Well, we're starting with not the z-score. Well, we're going to try and find the z value, but we're given the what? Probability. Okay, so that means we've got to start by looking inside your chart. Okay. Do the same thing. Set up probability versus z-score. So let's look at this. Look for this value. and you want to notice it's a small value, so it's probably on the negative side of your chart. Okay, and closest probability that's just below is 0.0853, and that gives you z-score of negative 1.37. And then you look for one that's just above 0.0869, and that's negative 1.36. Okay, take a look, do a quick calculation. Which one has the lower difference between those two and those two? Take the highest, subtract the lowest. Okay, and you'll find in this case that it is the top one. Ladies and gentlemen, it's not always the top one. It just happens to be in a couple of examples that I've chosen the top one because that's the number that comes out the best. So then you say, therefore, Z asterisk, just using the quick same terminology that they had there, equals negative 1.37. All right. Anybody need any help with that? All right. Let's do one more example. It's going to take us a little longer, but just to make sure we're on the right track. Okay, so the amount in kilograms of dirt store sells weekly is recorded for 15 weeks. Okay. So just remember that, ladies and gentlemen, when they record this is like a sample, because we're just sampling it for 15 weeks. Okay. So if we're given straight data, okay, what do we need to do? Well, the next thing you say, it says assume that the data is normally distributed. So what two things do we need in order to do normal distribution? Well, we need to know what the mean is, and we need to know what the standard deviation is. So what we need to do is take these values, use a graphing calculator, okay, and plug that one up and get the stats. Okay, so plug it in, okay, and again, when we find the mean, we're going to plug it in and we're going to get 43.67. Our standard deviation, because it's a sample, that's going to be the S at X one. Okay, it's going to be 4.45. Okay, so when you're given the raw data, don't forget you've got to do some calculations, and you can use the graphing calculator to find that. Okay, so now it says that the store needs to sell at least 35 kilograms to break even. What is the probability they do that? Okay. So remember, probability where X is greater than 35 or at least 35. Remember that this greater than symbol is not good in terms of using statistics. So what do we need to do? Change it to 1 minus the probability where X is less than, okay, 35. That's going to help us. Okay. Now, before we can go any further, we're going to take our data that we've collected or found from the graphing calculator. We're going to find our z-score. So z equals 35 is the limit we're looking for minus the average, and divide by your standard deviation. Okay. So z-score equals negative 1.95. It should be negative because it's lower. So let's replace our random variable x with our z-score. So it's going to be z is less than negative 1.95. Okay. Look that probability up in your z-score charts. Should get negative 1 minus 0.0256. Okay. Which equals 0.974 when you're done the calculation. So what does that mean? That means, therefore, you have a 97% chance that they will sell at least 35 kilograms, and that will allow them to break even. Okay, And folks, in business, as long as you know your business model, this is a good thing to make sure you know how to do. All right. Okay, we're going to keep on with this problem. We should have another question down below here. So now question number 2, how much dirt should be left on hand to be 90% sure that the store won't sell out? Well, how much dirt means, hey, what is the amount we're looking for? So it's kind of like the working backwards business where we got to find it. And if we want to be 90% sure, that's 0.90, which is our, it is our percentile, but it's also our what? Probability. Okay. So what we're looking for is the probability where x is less than x equals 0.90. Okay. This is the x we want to eventually solve. Okay. All right. So we got to work backwards. So again, use the percentile. Go to your z-score chart, and I'll do it over on the side. We'll do a probability versus z-score. Okay. Look for the one that's just below 0.9, and you should get 0.8997, and that would give you a z-score of 1.28. Okay, look for one just above 0.9015, which is 1.29. And again, do the differences between the two of them, which one has the lower finite difference between the two, and sorry, but again, it's the top one. Okay, so let's change this about. So if we know z is going to equal 1.28, we can rearrange our formula now. Okay, so if z equals 1.18, we can now use the z-score formula to work backwards. So remember, z equals our data value, subtract our mean, divided by the sample. Right? So what do we can sub in now? 1.28 equals x, which we're trying to find, subtract our average, which we know is 43.67, divided by our standard deviation from our sample, which is 4.45. Again, cross multiply and solve. I'll do a little fewer steps here. So cross multiply and you'll get 5.696 equals x minus 43.67. Move the negative 43.67 over to the other side and add it. You should get x equals 49.366. Okay, so therefore they should keep 49.4 kilograms of dirt on hand so that they don't run out. All right. So hopefully you had a good go with that lesson. Here is your homework today. Page 439, numbers 1 to 3. If you have any questions, come see me. If you're having trouble with the graphing calculator, ask to borrow one in class. Have a great day, folks, and enjoy this nice weather outside.